Okay, Trig students, this is section 3.3. I'm going to do some practice problems out of the homework assignment. I'm highly encouraging you to please look at the PowerPoint presentation that is posted in Google Classroom along with this video to help you do the homework here for section 3.3. Slide number 19 has all of the formulas for trig functions, for derivatives. So I'm going to quickly hit the high points here. So the derivative of sine of x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x, which I just want to point out is the same thing as secant x squared. We just usually write the square like between the secant and the x part. The derivative of secant x is secant x times tangent x. The derivative of cosecant x is negative cosecant x times cotangent x. Okay, and the derivative of cotangent x is negative cosecant squared x, which again is the same thing as negative cosecant x squared. Okay, same thing. Okay, so that gives you a bird's eye view. They go over how they derived some of that in the PowerPoint, but just wanted to make sure that you kind of had the ground rules. Now I'm going to kind of go through here and do some of these with you. So this first one, if we are supposed to differentiate, okay, remember when you're adding two things together, you differentiate each term separately. So the derivative of sine x is just cosine x plus 3/4 times the derivative of cotangent x. The derivative of cotangent x is negative cosecant squared x. So really, if we clean this up a little bit, this is cosine x minus 3/4 times cosecant squared x. Okay, that would be your answer right there. Okay, now we still have product rules and quotient rules to deal with. So on number 2 here, we're differentiating. Again, I'm going to call this like my f function and this my g function. And remember, if you're trying to find the derivative of f times g, the formula is fg times prime plus f times g prime. Not sure why that didn't come out very well. Okay, so the derivative of secant is secant times tangent. So y prime, the derivative of f, is secant x tangent x, and of course that's where I have a bad spot in my board, times, oh, they're using thetas instead of x's. That's all right. I'll go back and replace it later. Times tan x plus f is my secant x times g prime. Well, the derivative of tangent is secant squared. So we essentially here, if you see this, we have a secant x times tangent squared x plus secant cubed x. Now, I don't know if they'll take that, or if they would want you to factor out, you could factor a secant x out of both of those, and you'd be left with tan square x plus secant squared x. Oh, and don't forget, actually, this should be secant theta times tangent squared theta plus secant squared theta. I apologize. We should have a theta in there, not an x. Okay? So again, the product rule that we learned last time still applies. Okay? Let me clear the ink. Keep scrolling. Differentiate, again, on number 3. I'm not going to take the time to do it, but that is using the quotient formula. Okay, so don't forget the quotient formula. Now, this one I wanted to tackle because we actually have 3 things going on here. Okay, so on this one, we kind of have an F, we have a G, and we have an H. Okay, so I'm going to kind of extrapolate our product rule. Okay, if I have F times G times H prime, that is F prime times G times H plus F times G prime times H plus F times G times H prime. Okay, so we're just kind of expanding the previous product rule that only had the product of 2 functions. Now, if I've got the product of 3, I literally am just moving down whichever one. I start with the F prime, then the next one's G prime, the last one's H prime. So this would be F prime of X. Actually, I'm just going to call it Y prime so I don't confuse it with the other F. So F prime is just 8 times e to the X. Sorry, I got sloppy there. Cosecant X, okay? Plus F is 8X. G prime is still e to the X times cosecant X. Plus F is 8X. G is e to the X. H prime, the derivative of cosecant is negative cosecant cotangent. Why do I keep, oh boy, not sure what happened there. Cosecant X, cotangent X. Okay, so yes, I know that looks very ugly. But if you notice, every one of these terms, if I can kind of clean this up, have an 8 e to the x cosecant x. So 8 e to the x cosecant x. 8 e to the x cosecant x. So I'm actually going to pull that out. So I'm going to pull out an 8 e to the x cosecant x. Okay. Times what's left here, in the first term, it's just a 1, plus in the second term, it's just an x, plus, oh, that actually would not be a plus. We've got a minus in that third term. So that would be a minus x times cotangent x. Okay. And if WebAssign doesn't like this, they may want you to go back in and put parentheses. Oh my goodness, what happened there? Put parentheses around the object of your trig function. I don't know. Anyway, I don't know why that one shifted down, but okay, hope that helped. I also want to do number 5 with you. So it says find the equation of the tangent line to the curve at the given point. We've done this before, we just haven't done it with trig functions. So we're going to have to kind of go back in our memory banks here and remember our pre-calc. But in order to find the equation of the tangent line, we need slope, and slope is derivative. So the first thing we have to do on this one is find y prime. Well, y prime, the derivative of secant, is secant x times tangent x. Okay? And we have to evaluate that at the point pi over 6. Okay? So that's how we're actually going to find the slope, is to evaluate it at the x value at the point pi over 6. So secant of pi over 6, and remember secant is 1 over cosine, okay, times tangent pi over 6. Well, this gives me 2 over root 3 times root 3 over 3. If you're poking that in a calculator, make sure you're in radians, okay, not degrees, radians. So then, of course, these are going to cancel, okay? So this leaves me with a slope of 2/3. Okay, so here's my slope. Now, what do we do with that? We poke it in the point slope formula. Okay, so point slope formula. We have y minus 2 root 3 over 3 equals, the slope is 2/3 times x minus, my x value is pi over 6. Okay, now again, this 2/3 has to be distributed to both of those. Okay, so I'm going to keep working here to the right. This gives me y minus 2 root 3 over 3 equals 2/3 x. Let's see, if I take the 2/3 times pi over 6, 2 will go into 6 3 times, so I end up with minus pi over 9. Okay, and I don't know if at any time it's going to take one of these, but if we keep solving for y, okay, we are going to get 2/3 x minus pi over 9 plus 2 root 3 over 3. That should be the equation of my line. Okay, because we can't really combine the pi over 9 and the 2 root 3 over 3. I mean, we could try to get common denominators, but we're still going to have 2 terms in the numerator, so it's kind of a moot point. Okay, hope that helps. Now, I want to jump. Where do I want to jump? I want to jump to question 8. The 6 kind of baby steps you through. 7's got to watch it. 8's got to watch it too. But okay, let's look at 8. We're also going to do 9, but I'm going to need some room. So we just have to find h prime and h double prime. So first derivative and second derivative. Actually, I'm not so sure I need to do that. This is going to be the product rule, really. So instead of the theta, if that bothers you, okay, again, imagine this is your f and this is your g. If you want to put in an x, fine, just remember to put theta back in. Now to get the theta, you're going to have to, when you click on the box in WebAssign, it's going to pull up that little key thing over on the right-hand side. You're going to have to look through your symbols or your Greek letters, I forget where it's embedded, to find your theta, okay? So h prime is, again, going to be f prime g plus fg prime. So f prime is going to be just 1, because that's kind of like, you could rewrite this as x times sine x. So again, this is my f, this is my g. So f prime is 1 times g plus f times g prime. Well, that is cosine. Okay, so really we need to put it back in theta. This is sine theta plus theta times cosine theta. That would be h prime. Okay. Now, if we want to find double prime, of course, we have to find the derivative of the first derivative. So we're finding the derivative of the derivative. So double prime, this is h double prime, okay? The derivative of sine is just cosine. I'm going to keep it in terms of theta here. Plus, now we have to use our product rule again. So the derivative of theta is 1 times cosine theta plus theta times the derivative of cosine is negative sine. Okay, so to make this a little prettier, we would have negative, oh, actually these, sorry, as we simplify, I can combine those together. So we would have 2 cosine theta minus theta times sine theta. That should be your second derivative. Okay, so cosine theta plus cosine theta is 2 cosine theta. So we can pretty it up a little bit. Okay, now I want to scroll down to leave me some room here for 9 because it can get a little ugly. And again, there's a lot of watch-its on these. Okay, so use the quotient rule to differentiate the function. Now, so if we're using quotient rule, remember our quotient rule. Let me give you a reminder down here maybe. Okay, quotient rule. If I have f over g prime, that is f prime g minus fg prime over g squared. Okay, so the derivative of tan x is secant squared x. So f prime here, tan x is secant squared x. And then you have to take it times g, which is secant x, right? Minus my f is the whole numerator, tan x minus 1. That's why I put it in parentheses, because it's a binomial, times the derivative of the denominator. The derivative of secant x is secant x tan x. Okay. And then all of that is over secant squared x. Okay, now prettying up the top a little bit. Okay, this is going to leave us with secant cubed x. If I distribute that tan x, I'm going to have minus tan squared x secant x. And then plus secant x tan x. Okay, now that's the numerator. Okay, and that is all over secant squared x. Now, what I notice here is I have at least one secant in every term on top that I could cancel with one of the secants on bottom. So if I do that, it's going to take one of these, it's going to take that one, it's going to cancel with that one, and it's going to cancel with one of those and leave me 2. So this is going to leave me secant squared x minus tangent squared x plus tan x all over secant x. Okay, here's the deal now. I don't know if you all remember your trig identities. I know everybody kind of shudders when you say that word or say that phrase. Secant squared x minus tangent squared x. I hope you remember that is the quantity of 1. this equals 1. So this simplifies even further. This is going to give me 1. Oh my goodness, what just happened? The whole thing shifted. Will it shift back up? Nope. I have no idea what just happened. Okay, so this is going to give me the quantity 1 plus tan x over secant x. That's part A. Okay. That is part A. 1 plus tan x over secant x. Let me pretty that up a little bit. This is part A, and this equals f prime of x. Okay, for part A. Now, part B said simplify the expression for f of x by writing it in terms of sine x and cosine x, and then find f prime. Okay, so can I pretty up the original function first by converting everything to sines and cosines, and then find the derivative? Well, let's see. Okay, so tangent is sine over cosine, and secant is 1 over cosine. Now, on the top, I have to have common denominators. Okay, so I'm going to multiply the 1 here by a cosine x over cosine x. So what that's going to do for me then is I'm going to have a sine x minus cosine x all over cosine x. And then my big fat fraction bar, I've still got 1 over cosine x. Now, when you're dividing, you're multiplying by the reciprocal. So these are ultimately going to cancel. You're just going to be left with sine x minus cosine x. Now, the sine x minus cosine x is your original, that's your original f of x function. Okay, well now they want you to find the derivative of that. Well, that's super easy. Okay, so the derivative of that, the derivative of sine x is cosine x, and the derivative of cosine is negative sine. So you just end up with cosine x plus sine x. That is f prime. Okay, that's part B. Okay, now it says, are your answers to part A and B equivalent? Well, are they? Let's turn this back into an equivalent statement in terms of sines and cosines again. So this would be 1 plus sine x over cosine x all over 1 over cosine x. Again, same trick I did on part B. This is going to give me cosine x plus sine x over cosine x all over 1 over cosine x. Well, again, these are going to cancel. Okay, so all that's going to do is leave me with cosine x plus sine x. Are those the same? They are. So this is a big fat yes. Okay. Whew, that one was long. Okay, I think I just want to do one more, and then I'm going to call it quits, or I'm going to be having way too long a video. So let me clear that. Let's look at number 10. So for what values of x does the graph of f have a horizontal tangent? Now, in order for a tangent to be horizontal, that means the slope has to be 0. Okay, so how do we find slope? We take the derivative. Okay, so first step is to find f prime of x. So f prime of x, the derivative of x is just 1 plus 2 times the derivative of sine x, which is cosine. Okay, so 1 plus 2 cosine x. Now, again, if it's horizontal, means the slope has to be 0. So we're going to set 1 plus 2 cosine x equal to 0. That means 2 cosine x equals -1, or cosine of x equals -1/2. Well, when does that occur? First of all, remind yourself that cosine is negative in the second and third quadrants. Okay, so if you poke that in your calculator, if you put in the arctan, or sorry, not arctan, the arc cosine of -1/2, that gives you, in a calculator, it gives you 2 pi over 3. Okay. Hopefully you're using a good Casio, because if you put this in a Texas Instrument, you're going to just get lovely decimal. But cosine of x equals -1/2. Again, in your calculator, you put in the arc cosine. That's like the inverse cosine, shift cosine of -1/2. And you get 2 pi over 3. Now, that's the second quadrant. Okay? That's the second quadrant. It also occurs in the third quadrant. So in the third quadrant, what's equivalent to 2 pi over 3? Well, the equivalent to 2 pi over 3 is 4 pi over 3. It's 1/3 less than pi and 1/3 greater than pi. Okay? So that's second and third second and third quadrant. Now it says for what values, okay, again, but they want all values. And it says use n as your integer variable. Okay, enter your answers as a comma separated list. So essentially the 2 pi over 3 is going to give you that for every iteration around the unit circle. So you're going to have 2 pi over 3 and 8 pi over 3 and 14 pi over 3 and all of those. Every 2 pi you're going to keep reiterating and getting the same answer. Same thing with 4 pi over 3. You're going to have 10 pi over 3. Okay, and 16 pi over 3. All of those are going to give you the same answer. So we write the answer very generically. So I'm going to say my answer is going to be 2 pi over 3 plus 2 pi n and 4 pi over 3 plus 2 pi n. Now the n comes into play with how many times around you're going the unit circle. Okay, so if n's a 1, again, well, first let's start at n is a 0. Okay, if n is a 0, you're just going to have 2 pi over 3. If n is 1, you're going to have 8 pi over 3. If n is 2, you're going to have 14 pi over 3, and so on and so forth. Same thing with the 4 pi over 3. Okay, if n is 0, you have 4 pi over 3. If n is 1, you're going to have, what, 10 pi over 3. If n is 2, okay, you're going to have 16 pi over 3, and so on and so forth. So these should be your 2 generic answers. I wanted to make sure and do one like that in class so that you kind of understood what they're getting at. You could also get negative values if you put in a negative integer for n. But anyway, I think you catch the drift there. Okay. I think that pretty much covers it. Every problem has a watch it in addition. So the ones that I didn't cover, you still have the opportunity to see an example. Okay. But I hope what I did cover is helpful. If you have any questions, let me know.